Okay, welcome back to Heinzel Vision and the next unit, which is two-dimensional kinematics, things, objects moving in two dimensions. In order to deal with two dimensions, we got to look at something we call vectors and a little vector math. So the next couple days, we're going to be learning about vectors. So let's start with a simple example. Let's start with something you've been doing your whole life. Let's say I'm just walking around the room. I'm happy because everyone did so well on the kinematics test. Yay! So I start at what I call my position 0, and I walk to the right 3 meters. I stop, and then I walk to the right another 3 meters. Very easy to determine how far away I ended up from where I started, right? I started at position 0, I ended at 6. I add these together, I can say, well, I walked 6 meters. I can deal with that because it's in the same direction, right? I'm just in one dimension. Right? My x-axis just provides one dimension. I could also do 3 meters and then walk backwards 6 meters, like 6 meters backwards from where I started. And I would say, well, I started 3 to the right, but then I subtract the 6. So 3 minus 6 tells me I end up minus 3 meters away from where I started. Also easy to subtract because it's in the same direction. It's in one dimension. So when I have one dimension of motion, I just add and subtract basically. But what happens if I go 3 meters to the right and then I turn? And I go 4 meters now at a 90-degree angle. All of a sudden now I've opened up a new form of motion. I've opened up two-dimensional motion. And in order to figure out how far I went now, I don't just have to add 3 plus 4. I have to figure out the displacement from where I ended to where I started, which is this vector, which I'm labeling r. So two-dimensional motion brings up the need for vectors. Okay. And vectors are quantities with both a magnitude, which is our size, right, the 4 meters, and direction. So vector quantities are quantities that need a size and a direction, a specific direction. Not just one dimension, 2 dimensions. So there's two things we need to label something in 2 dimensions. And if I had 3 dimensions, I would need a magnitude essentially in 3 directions, right? I mean, think of it as your house. If you live at 430 Wrightwood, I don't know, make that up. That's really 2 dimensions, right? Wrightwood tells you the street, so that might be like your up and down or your side to side. And then the number 430 tells you where you are. So really, this is 2-dimensional motion. There's 2 numbers that are required to describe where you are. So vectors are things that require 2 or 3. We could do 3D vectors. We're going to leave that for the most part alone and deal with things in 2 dimensions. But just know that however many dimensions of space I have or that I'm dealing with, I need 3 quantities to describe that vector if it was in three dimensions. Okay, so you've already noticed, how do we draw vectors? We draw them as arrows. So the arrow points in the direction of the vector, and relative to the length is the magnitude. So if I draw it, this one would be like, if this was 5 meters in that direction, this would be 2.5 meters. So you don't have to measure it, but relatively you should draw them longer vectors, longer than the shorter ones. And basically there are a bunch of different quantities that we deal with that we need to use vectors. Some examples of those. Examples of quantities that in 2 dimensions require direction: displacement, velocity, acceleration, force, and momentum, all vector quantities. But there's not every quantity that requires a direction. There are a lot of things that do not require direction, and we call those quantities scalars. Scalars are things we measure that don't have a direction, like time. Seconds always count forward. I don't have seconds in a direction. Mass, speed. Speed is the scalar version of velocity, right? My speedometer always only says 30 miles per hour. It doesn't say 30 miles per hour, in the northwest direction. Distance versus displacement. We've already talked about that. Distance is just how far I went. It doesn't take into account the direction. And then energy, as we'll get to later on, also does not require a direction. So we have vectors, we have scalars. In order to deal with vectors, we're going to come up with a new set of rules to identify the magnitude and the direction and how we put them together. And we'll start hitting that in the next video.